Okay, this is reviewing for the final exam. Physics, obviously, Ms. Lule. This is designed for fall 2016. It might be exactly the same for any date after that. Okay, so compare and contrast. So here we have concepts. We have a whole list of concepts. Go through those very quickly, all right? And if you're like, yeah, got it, you're good. Or you can use this as a list to go looking through your notes in your journal and figuring out what it is you need to study. Go through all of those concepts. It gives you key vocabulary there for you to make sure you understand and know it. Okay, here we have a list of formulas that could show up on the final exam. I think actually all of them do show up on the final exam. And here's the formula chart that you will use for the final exam. Okay? So this is just the list of formulas. The formula chart actually provides more information, including the rearrangements of the formulas. So this is just there just so you have a quick reference in case you don't have this. Okay, next we've got 3 pages of practice calculations. I'm going to go through these super duper fast. And I invite you to have done them before. Go through and work out these problems before you ever watch this section of the video. And use this as a way to check your answers, or if you get really stuck in a problem, to figure out how to do it. Zooming on, question number 1. We have a 40 kilogram skateboarder leaves a 57 meter high ramp at a velocity of 28 meters per second. What is the skater's momentum at that instant? All right, so problem-solving process, identifying our variables, 40 kilograms, every number, write it down, 57 meters, 28 meters per second. All right, kilograms measures mass. The meters here, we're talking about how high the ramp is. That's going to be height. And meters per second is velocity. Or speed, depending on the circumstances, but it says their velocity, so we're going with it. Question is asking for momentum. That is a lowercase p. All right. Now, formula for momentum, and the only formula that I've given you that has momentum in it, right there in the formula chart, momentum is mass times velocity. Momentum, mass times velocity. Well, we have mass, we have velocity. Guess what, that height? Extra unnecessary information. All right, if momentum is my question, do I need to arrange the formula? No, I do not. So I can just plug in my numbers. So momentum is the mass of 40 kilograms multiplied by the velocity of 28 meters per second. (40 times 28 gives us 1,120. Now, units of measure, so we want to answer with significant figures and units of measure. Significant figures, I'm going to pretend that has 2 significant figures, ha ha ha. So if that has 2 significant figures, our answer needs to have 2 significant figures. So it's going to be 1,100. Units of measure for momentum are kilograms times meters per second. There is your answer. Question number 2, we have a 1,800 kilogram car moving 76 meters per second. If it takes 7.0 seconds to go 192 meters before the car comes to a rest, okay? So keyword there, rest. Remember, the rest means a velocity equal to 0, okay? So we have a velocity of 0. What force is required to stop the car? So kilograms measures mass, meters per second, we're measuring velocity, seconds, we're measuring time, meters, we're measuring distance. We have a velocity, we've got 2 velocities there. Because it comes to a rest, that's your final velocity. 76 is going to be your initial velocity. And the question is asking for us to solve for the force required to make this all happen. So if we're talking about force required to make this happen, well, let's consider that for a moment. We've got a lot of formulas, and I mean a lot of formulas in this class that have force in it, okay? The most classical ones we've got for force, we've got our work, force, distance, we've got force, mass, acceleration. Those are your classics, but we have another one down here talking about impulse. All right, we want to solve for force. We know mass, we know velocity, we know time. force, mass, velocity, time. Bingo, right there. Okay, so force is equal to mass multiplied by the change in velocity divided by the time. So notice it is a change in velocity, how much the velocity changed. The good thing is our final velocity is 0, so the amount of velocity actually changed was by 76 meters per second. So that makes it a little bit easier. So we're going to plug in numbers to get our force. The mass, 1,800 kilograms, multiplied by how much that velocity changed. It changed 76 meters per second. And we're going to divide that by the amount of time it took, which was 7.0 seconds. And we are going to plug that all into the calculator. Calculator says this lovely number, 1954228, 19542.85714. Significant figures, 2, 2, and 2, so we need 2 significant figures in our answer. Oh, lovely. All right, so this one should round that 5. So 1 and the 9, the 5 is going to round the 9 up to 19, up to a 20. So that kind of gets difficult. So it's going to be 2, 0, and then 1, 2, 3, 4, 5. So 4 zeros after it, 20,000. Significant figures off a little bit on that. Technically, it should be 2.0 times 10 to the 1, 2, 3, 4, 4. That's the correct significant figures. Rounding it pretty darn close is right there, 20,000. Units of measure, we're solving for force. Force measured in newtons. There will be nothing like that on the test, I promise. For significant figures. All right. Question number 3, we are asking what is the kinetic energy of an object with mass of 75 kilograms traveling 45 meters per second for a distance of 22 meters. Okay. Kilograms is mass, meters per second is velocity, meters is distance. The question is asking us to solve for the kinetic energy. Well, fortunately, that's a pretty easy formula to find because kinetic energy right there in your formula chart. Kinetic energy, 1/2 mass velocity squared. Don't forget squared. Okay. Kinetic energy equals 1/2 mass velocity squared. So we have mass, we have velocity, we want kinetic energy. Notice distance, extra unnecessary information. Anticipate an extra unnecessary information every single problem on that final exam. So exciting. Okay. So plug in numbers, kinetic energy. When I punch in the calculator, instead of putting 1/2, put 0.5, multiplied by the mass is 75, multiplied by a velocity of 45, make that 45 squared. You can punch it in just as it appears there into your calculator. Your calculator knows order of operations to square that first before it does anything else, and you get this number, 75937.5. Okay. So significant figures, we've got 2 significant figures in our original measurements. So it's 2 significant figures in our answer. The 7 and the 5, the 9 is going to round that 5 up to 6. So 76000. All right, 76,000 joules for kinetic energy. Next one, number 4. A motor is lifting a 15.0 kilogram box at a constant velocity. Question is asking for how much work has been done to lift the box 2 meters, 2.0 meters. All right, kilograms mass, meters is distance. Question is asking for work. Well, our formula for work is force times distance, but we've got mass and distance, okay? Key thing here, lifting, good thing to know. So if you kind of picture this, you've got some sort of something that's hanging and being lifted upward by some sort of a motor on the side. Okay? So how much work is being done? Force times distance. The force is going to be the weight. So we need another formula here. Force of weight is mass times gravity. Okay? We know the mass, we know gravity 9.8. We're going to multiply those together, put it into there to get our force. That force multiplied by the distance provided to get the work. So here we go. Force of weight is the mass, 15 kilograms multiplied by gravity of 9.8. Gives us 147. That number is plugging into our work times work is force times distance formula. So we have a work of force of 147 newtons multiplied by a distance of 2.0 meters. Calculator says 294. Okay, calculator says 294. Significant figures. We've got 3 in that one, 2 in that one, so our significant figures, we have 2 significant figures in our answer. 294 rounds to 290. Units of measure for work is joules. All right, question number 5. We have asking for the net force on a 3,500 kilogram car moving at a constant velocity of 45 meters per second, a distance of 180 meters. Mass, velocity, distance. Question is asking for net force. Force, net force, usually the same thing. All right, so force, looking at the value information we have here. We got mass, we got velocity, we got distance. And if you look through all of your formulas for force, you're not going to find any one that works. You're always going to be missing some sort of information. Okay? So force, mass times acceleration, we always need some sort of acceleration happening for there to be a force. So go back to Newton's 3 laws of motion. Okay? And what do we know about net force? Well, net force. If it's at equilibrium, which means all the forces are balanced, whatever force there is going up, there's an equal force going down. Whatever force you might have to the right, you've got an equal force to the left. Equilibrium. When we have equilibrium, what's our net force? 0. If our net force is 0, we're at equilibrium. Our motion, it's either at rest or has a constant velocity. Right here, that's the key. It says it's moving at a constant velocity, which means our net force is 0. 0 newtons. That's our answer. It wasn't a problem-solving process. It was a concept question disguised as a problem-solving process question. Question number 6. Hydraulic lift is used in an automotive repair shop. Takes 45 seconds to raise a 1,100 kilogram car 4 meters off the ground. Notice that one written 4 meters to mess with your head. Still number 4 meters. So we've got time, kilograms, mass. That 4 meters generally say, oh, it's distance, but if you think about this, 4 meters off the ground, we're raising it. That's actually a height. Okay. Question is asking for the potential energy given to the car. Well, potential energy is mass times gravity times height. Now, if you had thought, oh, well, this is distance. Remember, distance and height, same thing, just different perspective. Okay? And we do not need to rearrange the formula, so we're going to plug in the numbers. Mass 1,100 kilograms multiplied by gravity of 9.8 multiplied by a height of 4. We're going to assume 4.0 for significant figures, make life easier. And multiply that. Calculator gives this number right here, 43,120. Significant figures, 2. Safely assuming it's 2. 43,000 units of measure for potential energy is joules. We have a 250 hertz sound traveling through a liquid for 5.5 seconds. If the wavelength is 4.0 meters, it is asking for the speed. So hertz is frequency, seconds is time, meters is normally distance, but if you're careful, wavelength is 4.0 meters. So that is not distance, that is lambda. Wavelength. Question is asking for the speed. Speed, which is the same thing as velocity. All right, so velocity, distance divided by time, well, it doesn't quite work because we're talking about the speed of a wave. Velocity of a wave is the wavelength multiplied by the frequency. So we have those two, wavelength and frequency. All we have to do, because that is the question, just plug in our numbers. So wavelength 4.0 meters multiplied by frequency 250 hertz. 4 multiplied by 2,500 or 250 gives us 1,000. Okay, so significant figures technically should have 2 significant figures, but we're not putting a decimal point in there because then that makes it 10 rather than 1,000. So we're going to just call it 1,000 for right now. Significant figures should technically be 1.0 times 10 to the 3. But we'll leave it at 1,000. Units of measure for velocity of a wave is meters per second. Question number 8. 1,100 kilogram car yet again. Moving 26 meters per second. Takes 9.0 seconds and 32 meters for the car to come to a rest. What is the force required to stop the car? So this is kind of a repeat of the same question before that we did on this one. Let's see if you get it this time. Velocity, time, and distance. The force is the question. Okay, so force is my question. Lots of formulas for force. If you look through it carefully, all the variables provided, you will find we have one of mass times the change in velocity divided by the time. Again, that coming to rest, that's your final velocity. Here's your initial velocity. The velocity changed by 26. So mass, 1,100 kilograms multiplied by 26 is a change in velocity divided by the time of 9.0 seconds. Do your math in the calculator. 3177.7777 on forever. That's what the calculator says. 2 significant figures. 33,200 units of measure newtons for force. Question number 9. Person using a force of 750 newtons to push a box. How much power does the person need to push the box a distance of 4.0 meters in 35 seconds? Okay, so newtons is force, meters is distance, seconds is time. Question is asking for power. Well, if you look at your formulas for power, power is work divided by time. We don't have work. However, work is force times distance. We're going to have to use 2 formulas to solve for this one. So first we solve for the work and then plug into the power formula. So work, force of 750 multiplied by a distance of 4.0 meters. 750 multiplied by 4.0 gives us 3,000. And we're going to take that. Power is work divided by time. Plug in that right there. 3,000 divided by a time of 35 seconds. And the calculator says 85.714 blah, blah, blah. Significant figures. 2, 2, and 2. So our final answer needs 2 significant figures. 85, that 7's going to round the 5 up to a 6. and units of measure for power is watts. All right. We have a 4,500 kilogram truck moving 8.4 meters per second. Travels for 145 seconds. How far did it travel? So mass, velocity, time, and the question is asking for distance. Okay, so distance and displacement, speed, and velocity, very comparable. If it's not talking about direction, we can kind of make them synonymous. So we are going to solve for, on your formula chart, we have this velocity is displacement over time. Speed is simply distance over time, but this is the question. So we need to rearrange that formula going into the triangle. We have distance on top, plug in our numbers, rearrange. Distance is going to be equal to speed multiplied by the time. So distance is the speed of 8.4 meters per second multiplied by a time of 145 seconds. 8.4 multiplied by 145 gives us 1,218. Significant figures 2. So 1,200 meters is your answer. We have a man who took his dog for a 2-hour walk. In the first 30 minutes, they traveled 2.5 kilometers to the park, then walked 1.5 kilometers to a friend's house. Then in the final 30 minutes, they walked 2.3 kilometers back home. What was the man's average speed for the trip? Blah, 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 blah. Okay, so this is one of those average speed for the trip questions. When you have these sort of things, all you have to do is you need the total time, you need the total distance. Okay, for this average, the average speed for a trip, you need the total distance and you need the total time. Now, if you read the question carefully, all right, we do have the 75 kilogram mass, but we're not going to use it. Okay? Total distance, total time. Read the question carefully. Okay? It was a 2-hour walk. There was 30 minutes later on, and there was 30 minutes, and blah, blah, blah. The pieces don't matter. All that matters is the total time, which was 2 hours. Total distance, that's going to be a little more challenging because it was 2.5 kilometers to the park. Then it was 1.5 kilometers to a friend's house. And then it was 2.3 kilometers back home. So you do have to add all those up. So 2.5 plus 1.5 plus 2.3 gives us total distance of 6.3 kilometers. Okay, so that speed is distance divided by time. Distance 6.3 kilometers divided by a time of 2.0 hours gives us 3.15 in the calculator. Significant figures. 5 is going to round the 1 up, so 3.2 kilometers per hour. And it's kilometers per hour because this was kilometers, this was hours. Units of measure, kilometers per hour. Number 12. We have a bicycle. 5.3 meters per second. And he uniformly accelerates as he goes down a hill and has a new speed of 6.7 meters per second. It took 4.2 seconds for him to change his speed. Okay, and then it asks for the question. So meters per second, that's velocity, meters per second, velocity, seconds time. Question is asking for his acceleration. Well, two velocities in time. Acceleration is final velocity minus initial velocity over the change in time. Find that on your formula chart, not a problem. So final initial, which one happened first? Well, he's going 5.3 and then he accelerated down a hill and then he was going 6.7. So this is your initial, that's your final. So acceleration is your final, 6.7 minus initial 5.3. Divide that by the time, 4.2 seconds. 6.7 minus 5.3. Make sure if you're going to do this all in the calculator once that you put parentheses around what's in your numerator. Parentheses 6.7 minus 5.3. You need to subtract those before you divide the 4.2. Okay. 0.3333333 is your answer. Significant figures, just 2.33 meters per second squared. Units of measure for acceleration. All right, the next question, number 13, is for pre-AP only. Now, regulars, you can do it if you want to, but it will not show up on your final exam. Okay, so we have here a cup of water is attached to a string, is whirled at a constant speed of 3.4 meters per second in a horizontal circle with a radius of 6.5 meters. What is the centripetal acceleration of the cup? Okay, so our numbers, we have 3.4 meters per second, 0.65 meters, and that's a velocity. That normally is a distance, but if you read it carefully, it says radius, because it's spinning around a circle. So that is actually radius. And the question is asking for the acceleration, specifically the centripetal acceleration. All right. Right there. Centripetal acceleration, tangential velocity, and the radius. So centripetal acceleration is the velocity, the tangential velocity, which is that, squared divided by the radius. So that's our question, no need to rearrange. 3.4 squared divided by 0.65 gives us 17.7846. 17.7846, two significant figures, so the 17, 7 after that, rounds it up, so we get an 18 meters per second squared. Units of measure for acceleration. All right, question number 14. We have a 75 kilogram runner, has 1,900 joules of kinetic energy. All right, that's mass. Question is asking for the velocity or speed of the runner. Well, our formula for kinetic energy is 1/2 the mass times velocity squared. So we have the variables. We just need to rearrange it to solve for the velocity. So we have the variables. There's the formula rearranged to solve for velocity. So the square root, velocity is equal to the square root of 2 times the kinetic energy divided by the mass. Make sure all of that's in the square root. Okay, so when you punch this into your calculator, well, let's plug it in right here. 2 multiplied by the kinetic energy, 1,900, divided by the mass of 75. When you do this in the calculator, you need to make sure that it all goes into the square root. On these calculators, square root symbol right here, hit the second, come down here to about next to the 7. That gives you the square root. Type it all in. 2 multiplied by 1,900 divided by 75. Close the parentheses. Calculator gives you a beautiful answer. 7.11805, etc. Significant figures. 2 significant figures in original measurements. The 7 and the 1 after that does not round it up, so 7.1 meters per second for velocity. Last calculation, again, this is a pre-AP only. This is obviously the collision thing going on, so we're dealing with conservation of momentum. All right, we have a 2 kilogram mass. We have another mass. The 2 kilogram mass is going 3 meters per second. This one is going to be at rest because it's not indicating a speed. And then once they've collided, they're now going 1 meter per second. So it's asking for, the question is asking for the mass of that block right there. So here we go. How are we going to figure this out? Well, conservation momentum. We know the momentum. Sorry, we know them. Okay. We can calculate here the momentum of the system because this one has momentum of 0 because it's not moving. Momentum, mass times velocity. 2 times 3 is 6. 6 plus 0, the net momentum is 6. Which means now that they're connected over here, the net momentum is still 6. However, the velocity is only 1. So if the velocity is only 1, we want to find the mass of the whole cart. The mass of the whole cart is the momentum divided by the velocity. 6 divided by 1 is 6. So the mass of the cart, the mass of the whole train thing, both blocks combined, total mass is going to be 6. But that one's 2, so the mass of that one right there is 4 kilograms. So 4 kilograms is the mass of the other block. And that is your review for the final exam. For the details on this, I do a PowerPoint in class, kind of like going through it a little bit. But studying on your own is probably your best option. Good luck.